So this idea of indifference, split body, and the body as both a possessed and performing body. The idea that a part of the body is possessed by another person in another place, and a part of the body can perform with its own agency. But it's very interesting when your arm is moving without your own agency. It becomes alienated from your body structure. Your body moves, but you have neither initiated that movement, nor are you in any way controlling those motions. So this idea of the body being a host for multiple agency, the body becoming a split body, not a split mind and body, but a split body physiologically. Can we go to the motion prosthesis animation near the bottom? That one? Yeah, thanks. This is a performance in Ljubljana. Again, this was a local performance, but I also often had a head-up display so I could see the person who was programming my body. So there was a kind of an intimacy without proximity, an intimacy without skin contact. Okay, next slide, please. Again, another kind of split body experience, and I'm showing the animation to indicate only 3 degrees of freedom, up, out, and with a bend. But if you imagine these movements are happening simultaneously, you can generate 64 possible combinations. But instead of just simply being, computer controlled, what we did to, in a sense, make the performance a bit more emotive was we constructed an avatar imbued with genetic algorithms which altered its behaviour during the performance. So it was the avatar that actuated my upper body, whilst the lower body performed with its own agency. So here the body is possessed by an avatar. The body itself becomes a prosthesis, enabling an avatar to perform in the real world, or to partially perform in the real world. The flowchart, can we go to exoskeleton in the next video, please? And the motion prosthesis performance was a kind of an inverse motion capture system. So if we're putting electrodes on my body, I move and the computer model moves. But imagine if the opposite is possible. Instead of me actuating a computer model, the computer entity imbued with a rudimentary artificial intelligence can activate a surrogate body. In 1997, as well as experimenting with manipulators, I was intrigued with mechanical locomotion, especially six-legged walking machines. And the exoskeleton robot was constructed with the help of F-18 in Hamburg, and we did this in 6 months. And in this performance, the body is on the machine. The movements of the machine are activated by your arm gestures. So by making different arm gestures, the magnetic sensors on your arm joints indicated the position of your arms, and you were able to select whether the machine went forwards, backwards, sideways, left and right. It could also squat and stand and turn on the spot. This was the first performance I've done with my clothes on. And the reason for this was that when I first tested this robot, it was hitting the concrete floor so hard that the shock waves through the machine and up my body were quite severe. In fact, I couldn't really stand on the robot without fearing that I might get some spinal cord injury. I mean, in the video, the robot looks a little smoother than it really is. It's a very powerful and jerky machine. So the only way that I could really stand on the robot, aside from insulating the rotating turntable, was to wear shockproof boots. And when I realised I had to wear boots, it was only kind of logical that I would wear some clothing as well, much to the disgust of friends, I might add, who thought I should be on the robot with boots only. These performances, I guess, are about this idea of translating human bipedal gait into a six-legged walking insect-like locomotion. The next one, which is an animation at the very bottom called Hexapod. We tried to come up with a design, and this was done with the assistance of Inman Harvey at the Evolutionary and Adaptive Systems Group at Sussex University, coming up with a design for a robot that was more physically coupled to the body. And the idea with this performance was that if I lifted one leg up, 3 robot legs would lift and swing forward. If I lifted the other leg up, the other 3 legs would lift and swing forward. So simply by stepping up and down on the spot, the robot would move forwards. And by turning my body, the robot would walk in the direction that I was facing. This robot, which we built, which was 5 meters in diameter, took a few steps forward, fell over sideways. It was never successfully built in the design that you see here. Even though we use these 3D models and animation to try to simulate and to try to anticipate some of these problems, when you're building something 5 meters in diameter, the tension, fatigue, friction, you're functioning within a 1G gravitational field, it becomes very, very difficult to anticipate everything. So, this was the animation for the exoskeleton, which was a bit more successful in terms of anticipating what the machine could do. But you can determine the visual scale of the body on the machine. You can experiment with some of the movements and how they might appear. So it's really interesting and animation and simulation that can be done. This is also using steel cylinders, and the robot, in fact, that we next construct, we had to... Oh, wow. Okay. Can you go back, please, Chris? Through the arrows. Yeah, thanks. Okay. We had to change our ideas about the design altogether. Because of the weight problem, I decided I would actually be walking on the ground. So I'm within the chassis of the machine. There's a lower body exoskeleton, the upper body one never happened. Next slide, Chris. Side view and the next one. And this was the final result. This was a performance in Gallery 291 in 2003 in Hackney in London. And instead of using pneumatic cylinders, which a cylinder this big would weigh about 15 kilograms, which contributed to the really large weight of this big machine, I decided to use pneumatic rubber muscles. These are specially reinforced rubber tubes that are effectively very, very strong muscles. If you squirt something like 1 bar of air pressure, the muscle becomes a kind of spring. But 7 bar of air pressure, the rubber muscle expands in girth, contracts 20% of its length, producing a strong pulling force. And so it does the job of a cylinder, but it only weighs about 500 grams.